Hello everyone, I'm Professor Rahul Jain, and today we're diving into one of the most intriguing objects ever detected passing through our solar system, 3I Atlas. In this video, we'll explore what it is, how it was discovered, what makes it special, the key scientific details known so far, and why it matters. Let's begin. The object known as 3I Atlas, also designated C2025N1 Atlas, was discovered on 1 July 2025 by the Asteroid Terrestrial Impact Last Alert System, ATLAS Survey Telescope. n.wikipedia.org. It is classified as an interstellar object, meaning it originated outside our solar system and is just passing through. n.wikipedia.org. The 3I prefix stands for third interstellar object ever confidently detected, after 1I Oumuamua and 2I Borisov. Planetary Society. So, in short, 3I Atlas is a visitor from beyond our solar system, giving us a rare window into material formed around a different star. Several features of 3I Atlas make it remarkable. 1. Trajectory. Its orbit is highly hyperbolic, eccentricity 1, which means it is not bound to the Sun. It will enter, swing through, and leave. 2. Speed. It is among the fastest such objects ever recorded entering the solar system. 3. Size and brightness. Early estimates suggest it may be larger and brighter than previous interstellar objects, which raises opportunities and questions for scientists. 4. Composition clues. Observations show it is unusually rich in carbon dioxide, CO2, relative to water, a feature atypical for many comets in our solar system. 5. Scientific insight. Because it comes from another star system, studying it may tell us about planetary system formation beyond our own. Discovery. 1 July 2025 by Atlas Survey. Pre-discovery, pre-covery images show the object had been captured earlier, for example 7 May 2025, before being recognized. Observational campaigns. Major telescopes such as the Hubble Space Telescope, HST, James Webb Space Telescope, JWST, ground-based observatories and space surveys have been engaged. Key perihelion passage. It will, or did, reach perihelion, closest approach to Sun, around 29 to 30 October 2025, at about 1.4 astronomical units, AU, from the Sun. Closest approach to Earth is safely far away, 1.8 AU, so there's no impact risk. Let's summarize what we know, and what remains uncertain, about the nature of 3I Atlas. Nucleus and size. The exact size of the nucleus remains uncertain. Some estimates suggest tens of kilometers in diameter, but there's large margin of error. The nucleus appears surrounded by a coma, cloud of gas dust, and perhaps a faint tail as the object outgasses closer to the Sun. Outgassing and composition. Observations show a strong presence of CO2 gas escaping the object. For example, the Spherex Space Observatory found a bright CO2 cloud around 3I Atlas, with a mass loss rate of 70 kJ, while setting strict upper limits on water vapor, 4.5 kJ, at the time of observation. Near-infrared spectroscopy with JWST found an unusually high CO2 to H2O ratio, which could point to formative conditions different from many solar system comets. The surface reflectance, reddening, and spectral slope resemble D-type asteroids, common in outer solar system, in one analysis, raising questions about its makeup. Orbit and motion. The orbital inclination is small, close to the plane of the planets, the ecliptic, which is interesting because many interstellar objects might be expected to come at more random angles. Because it came from interstellar space, it likely traveled for billions of years before reaching our solar system. Some analyses estimate ages of 3 to 11 billion years or more based on cosmic motion modeling. Given its unusual traits, scientists are asking big questions about 3I Atlas. Natural versus technological origin. Some researchers, notably Avi Loeb and colleagues, have considered the possibility that 3I Atlas might be a technological object, i.e. alien probe, rather than a simple natural comet. Their paper is the interstellar object, 3I Atlas alien technology explores this idea. They point to its low inclination, its alignment with the ecliptic, its trajectory, and the possibility of non-gravitational accelerations as possible supporting features of a technological object. However, the vast majority of astronomers treat it as a natural object. They caution extraordinary claims require extraordinary evidence. Where did it come from? If natural, it may have formed around another star, then been ejected into interstellar space, traveling for eons before entering our solar system. Determining the parent system is extremely challenging. Could we intercept it? Practical interception is very difficult. A study suggested that a probe launched after its discovery would require an extremely high delta-v, change in velocity, beyond current capability. Rare opportunity. Interstellar objects are exceedingly rare. So far only 3 have been confidently detected. Each one provides a unique window into the cosmos beyond our solar system. Comparative planetology. By comparing 3I Atlas to solar system comets and asteroids, astronomers can test how general or unique our system is. Public imagination and science outreach. Objects like this spark curiosity, engage students and public alike, and drive interest in space science. Very useful in education. Technological and methodological push. Observing such fast, distant objects pushes telescope capabilities, spectroscopic techniques, and our readiness to respond to future discoveries. Philosophical implications. The possibility, even if remote, of non-natural origins forces us to think about our place in the universe, how we search for extraterrestrial intelligence, and how we define natural versus artificial objects in space. Observational campaigns will continue as 3I Atlas moves away from the Sun and out of our view. Some key moments, such as perihelion, were unobservable from Earth because the object moved behind the Sun relative to Earth. Researchers will refine estimates of its size, shape, composition, spin state, and dust gas emission as more data are analyzed from JWST, HST, ground telescopes, and space assets. Future instruments, for example the upcoming Vera C. Rubin Observatory, may detect many more such interstellar visitors, enabling a statistical sample. Theoretical modeling will explore formation scenarios, how an object could be ejected from another star system, dynamical histories, and potential implications for interstellar transfers of material. Within the educational sphere, 3I Atlas offers case study material for courses in astronomy, planetary science, astrodynamics, and science philosophy. To summarize, 3I Atlas is a third confirmed interstellar visitor, a body from beyond our solar system. It stands out due to its hyperbolic trajectory, high speed, and unusual composition, rich in CO2, low in water. While most likely a natural object, its properties invite provocative questions about origins and nature. It matters because it expands our knowledge of the universe, informs planetary system science, and stimulates both research and public interest. Thank you for watching. If you found this video helpful, please like, share, and subscribe for more educational content. I'm Professor Rahul Jain, and I'll see you in the next video where we dive deeper into interstellar objects and what they tell us about the cosmos.